I really would just like to speak of him as a dear friend. I first met Robert Sungenis in cyberspace almost 20 years ago, and I remember how excited we were that he was a true believer in the traditional doctrine of creation. And right from the beginning, what I've always loved about Robert Sungenis is that he loves the truth and he will follow it wherever it leads, because he knows God is the truth. And when we first met, and Robert first spoke at a Kobe Center conference, he was something of a celebrity in the Catholic world and being invited into the limelight. But when he took certain positions that he knew were correct, but were politically incorrect, he soon found himself no longer sharing the limelight. And it didn't bother him, because he's not interested in the limelight. He's just interested in being one with God and proclaiming the truth. And so that's the greatest introduction I think I could give to any speaker at this conference. And I'm very grateful to God that he's given us such a great champion of the faith as Robert Sungenis. And I know that you'll be blessed by what he's going to say. Thank you.
Thank you, Hugh. That is very touching. I appreciate that very much. I can tell you all the pain that went with the statements you made. But as I learned this morning, everybody's got their story. Everybody's got their sorrow that they've gone through to get where we are today. And that includes you. The fact that you're here, I'm sure you have your own stories to tell about the rough road you've experienced. At any rate, we're here to talk about science and theology and the Bible, and so let's get right into it. In all my years of dealing with this, and I was into science when I was a child. My father was a doctor, and I used to do experiments for him and take cultures and tell him what medicine to give. Of course, he made a final decision. It wasn't up to me when I was 12 years old, but I was into science heavy. I don't know. I had my own chemistry lab that my dad built for me in our yard, and had heat and air conditioning and everything. So I spent a lot of time back there, and I was forever reading books about science, and so it was a whole world for me. And then after I became Catholic again, because I had left the church for a while, and I came back when I was 19 years old, and I saw how far the church had drifted, not only from its view on science, but its view on the Bible, its view on theology, and just about everything, social issues, and it's just not what it used to be. And that's why we're here. We're here to try to bring the church back to, at least with the power that God's given us, to proclaim the truth, and hope that someday, somewhere, the hierarchy will see it, reverse course, and bring us back to where we were before. So we have a lot of work to do, as you can see. Let's deal with science as it is today. Let's get a good picture, a good perspective of what we're dealing with. What kind of monster are we dealing with here? You have to know, you have to identify who you're dealing with in order to be able to combat them. If you don't know what their armament is, or where they're located, or how many generals they have, or whether they have nuclear bombs or just, conventional weapons, you have to know all this, okay? As in wartime, well, we're in a war. This is a war. And it's not going to stop until Jesus returns. And so we have to know the enemy. Who are we dealing with? Well, there's a very famous quote, and it's in many of my books, and it's from a man named Richard Lewontin. Anybody ever heard of him? From Harvard. And he has a quote, Hugh uses it all the time, and there's many other people that use it. But basically he said this. He says, look, we know our evolutionary theory doesn't work, but it doesn't matter to us. Because our whole perspective here is not to let a divine foot in the door. Okay? So it doesn't matter what arguments we bring up to them. You could have the best arguments in the world. You could corner evolutionary theory in about 5 minutes. Maybe Father Rippinger did a pretty good job of it, I thought. There were some statements he made that if I were an evolutionist and I had some logical sense, I'd just say, let's just give up. How are we going to get past the arrow that the atomic bomb that he just laid in our field? Okay? It's easy. But there's another element here, apparently, for Dr. Lewontin of Harvard University. And that is, we don't care what you say. Because we're not going to let a divine foot in the door. So now we know what we're up against. Okay, this is the devil at work. All right? And that all happened, of course, in the Garden of Eden when God said, keep away from this tree called the knowledge of good and evil. Because if you eat of it, well, then you're going to have to deal with evil. And you're going to have good and evil in your world. And that's the element I think that we need to reinforce in this conference. And that is, we are dealing with an evil element. It's not just intellectual. Okay? It's not just biological, it's not chemical, although that's all included. Okay? We're dealing with an evil entity who will twist the truth as much as he did in the Garden of Eden. And he will do so well that he will try to make it look true. And he will be successful. Okay? So here we are. We can have all the great philosophical arguments, all the great scientific arguments, but that's what we're up against. But this is the job that God gave us, to preach the gospel. And you know, the gospel to men, Paul says in 1 Corinthians, is foolishness. Why would your God want to do that? Preach to people who don't really care and, hope for the best? Well, Paul says whatever is foolishness to men is wisdom to God. Because God's looking for those certain few people who will hear the truth, respond to it, and live by it, and thereby he builds his kingdom. And that's what we're all here for, to build God's kingdom. Okay? So we go out because we know there will be people who respond. We just have to search for them. Most of the people we talk to will think we're crazy. That's what we got to expect. Okay? And you think you're crazy, they think you're crazy because you believe in creationism. What do you think they believe when I tell them that the sun goes around the earth? We can basically say that modern science, I'm not talking about science, but I'm talking about modern science. Modern science today is designed for one thing: keep the earth moving, keep it in the remote recesses of space, have it exist or come into being by time and chance. Okay? That is their goal. Why? Because that is the least platform that they can have in order to get God out of the picture. Okay? They can't fight the fact that we exist, human beings, and we do have this beautiful earth like nowhere in the universe. Okay? So what's the best way to deal with that? Well, let's put the earth out here in the corner, no signpost saying, here you are. Keep it out of the center, definitely. Okay? Because what does it mean if you put earth in the center? Well, that smacks too much of God, you see. That takes the time and chance element away from it, and that makes it look like it was put there by a designer. So at all costs, keep it out of the center. All right? And when you do keep it out of the center, make sure you put it out in these remote recesses of space where you have dust and stars and no life, and so that we can develop this theory that it all happened by time and chance, by a big bang or whatever, and it just happened, and here it is, and there it goes. We live, we die, and that's it. It's over. And wouldn't that be a great place for a scientist to put himself, especially a scientist who lives an amoral or immoral life? Of course. Because what is the primary concern of every human being that God's built into him? As St. Paul says in Romans 1, it's a conscience. He knows God exists. He knows he should worship God. He knows he should give thanks to God for all that he has. It's right there in Romans 1, verses 18 to 20. He knows all this because it's been put in him. He can't avoid it. So every time he sins, no matter how he might convince himself that it's okay, he knows he's sinned. He knows he's committed evil. And he will suppress his conscience. He will suppress the knowledge of God as much as he can so that he doesn't have to live under the guilt. And what's the easiest way to assuage that guilt? Make up a universe that doesn't have a God in it. And that way you won't be responsible to anybody for your sin. And these guys go to work every day in their white lab coats, and they've just sinned the night before, and they're trying to figure out a way in the laboratory that they can get God out of the picture because of the guilt that they carry to their jobs, to be very practical with you. Okay? So it's very simple. Life never changes. It's always the same, just in different colors and different clothes. Okay? And that's what we're dealing with. Modern psychology is the same thing. Modern psychology was developed so that we could get sin out of the way as the cause for our problems. Okay? Now it's all psychological. Now, it's not to say that psychology doesn't have some merit. It does, maybe about 10% of it. But most of it is to get away from the idea of sin. That's why Freud developed his theory of psychoanalysis. The id, the superego, and the ego. So that we could blame it on the past or our parents or some mixture and confusion we had in our childhood or whatever it is. Okay? Modern medicine. It's designed to treat man as a chemical animal. I know, because my father was a doctor, and I grew up with that stuff. And I said to my father when I was thinking about being a doctor, I said, first of all, how much do I know about the human body? On a scale of 0 to 100%. And he said, maybe about 2. And that's after 30 years of medical practice, okay? He says, there's systems in the body, they have no clue what's going on, all right? Now, they won't let you know that. They'll make it sound like they've got it all figured out. And I said, well, then why should I be a doctor? So I asked him another question. I said, of all the people that you've seen in the last 30 years, what percentage of them are really sick? And you have to use medicine to cure them. And he said, maybe about 20. He said, the other 80% I can cure with aspirin and a good talk and send them home, and they'll be okay. Okay? So what does that tell us? And then a few years later, he said, I'm not too sure about the aspirin either. So now that we know who the enemy is, and who's behind it, the camouflage they want to put up is we're science. We're science men. We're white lab coats. We're guys who are objective. We don't see things the same way you normal people do, or you people in the society. We're a notch ahead of you. We're up in a different level because we are objective. When we look at the data, we don't see it in favor of this or that or the other thing. We look at the data and we try to make an objective conclusion. Well, what I would say is there may be an ounce of truth in that, but that's about all. Okay? Most of the scientists we have to deal with, and I'm talking about any science, archaeology, paleontology, cosmology, and cosmology is actually the worst. Okay? Medicine, you go down the list. No, they have an agenda. These people have an agenda. And what was that agenda? Well, the same one that Richard Lewontin told us. We know all these theories have problems. Most of them don't work. But we're not going to let a divine foot in the door. Okay? So that's not being very objective, is it? No. There's a lot of subjectivity going on in science today. All right? And we'll see as I go on here. So one way we have to fight them is that we need to know the science better than they do. Okay? We need to know the science better than they do. And that's hard, because science is not easy. But you'd be surprised. But once you start setting your mind to it, and you begin to look at this stuff, and you see where they're going with it, you see their interpretation, and you're scratching your head, say, well, how did you get from A to B? All right? And then you start figuring out that, well, this wasn't an objective conclusion you made. This was something that you had wanted to see produced, and so you interpreted the data, in light of where you wanted it to go. Okay? So we need to use the science in order to give an objective conclusion to what the data gives us. And of course, that's not always easy either. Because as Christians, we may not come to it as objectively as the average man may want us to. And that's what they accuse us of. That we have an agenda. And that agenda is to bring God into the picture. You see? So it's half a dozen or six of the other, or a catch-22 situation, let's say. So there's a middle road there that we have to establish, and that is, okay, well, let's deal with the science itself. We could pretend to play their game, and that's what I do a lot of times. I will play their game knowing that I do come to it subjectively in the sense that I do believe God exists, God created it, God designed it, and that's why the data is leading to a certain place, because God is behind it. But I can also play the game and say, all right, let's just pretend God isn't involved. Let's just deal with your data as data and see what it says, see where it takes us. Okay? And that's what Hugh does that a lot. As much as he has preached up here about all these saints and all those quotes and all this, it comes down to a point where he has to look at the data and he has to give the right interpretation objectively to this data, whether or not we inject God into the picture or not. Okay? Now, I'm telling you all this because this is what led me to, well, it's gone now, but any key? Okay. Space bar. Okay. See? The wonders of technology. So we must deal with the science on an objective level, number one. And the reason we must do that is because the church, by and large, has surrendered its authority over science in our modern day. Okay? It has basically said that science is its own domain and ecclesiastics is another domain, and if the two happen to overlap, well, the farthest the Catholic Church will go today is to say, you can say whatever you want over here on the science side as long as you say that God exists. Period. Okay? Well, is that any way for a good Catholic Christian to live? Is he going to allow the scientist to say anything he wants, basically? And The Christian can't say a word now because, well, as long as you believe God exists, I guess it's okay you say it. And you can teach my children that. And if the Big Bang Theory happens to make atheists out of them, well, you know, that's just the way the cookie crumbles, okay? When this turns off, I'm going to turn it off for good because I don't want you looking over there. I want you looking over here, okay? Pay attention. It's very important stuff. This we'll get to in a second. I just wanted to show you some of the stuff we're going to be looking at. Okay, so the church has surrendered its authority over to science in the area of modern science. Now, that's not the way it used to be. It used to be such that the church took charge of anything science said. Now, in earlier centuries, there wasn't much science, per se, like we have today. Science really didn't develop until like 1700s, 1800s, at least the modern science that we're talking about. So the church didn't really have much of a problem dealing with science prior to that, but now we do. So we need to regain that, okay? And how do you regain that if you've already given it up to a certain extent? For example, in the 1800s, the church just basically surrendered the Galileo issue, even though the church 200 years prior had condemned it as a formal heresy. Okay? Now we can talk about what level of authority that condemnation was. That's a big discussion. And maybe we can have that in the question and answer period. But, you know, on the rung, let's say there's 10 rungs of authority for the church, it's up there at least on a 4. Okay? That's pretty high. But the church basically surrendered itself to the fact that, well, in the 1800s, the church decided that the popes of the 1600s made a mistake. We had 2 popes, Paul V and Urban VIII, who both declared it a formal heresy. Now, they didn't sign their name to it, but they did take the recommendation of the Holy Office, the highest authority in the church under the Pope, who said it's a formal heresy, and the Pope approved it. Not only did he approve it, but he sent letters out to all the papal nuncios in Europe, all the universities in Europe, and he told them that this was a declaration of the Vatican as of 1633, that it was a formal heresy to believe that the earth revolved around the sun or moved at all. Okay, not even rotated on its axis. That's pretty heavy. Okay. When I saw that, I just said, what in the world happened? Okay, and we know what happened. The devil came in there and started to deceive us little by little until 1820, when Pius VII, a very weak pope, unfortunately, and he actually, you know, well, there's a long story about him, but he was bamboozled by a cardinal, Cardinal Airy, to accept the heliocentric, or to at least give it some leeway in the discussion and not have it chalked up as a formal heresy. And Pius VII gave in. And he allowed a book to be published that was defending the heliocentric system by a man named Canon Satelli. Okay, so there's where it began to crumble, 1820. And then 1835 came along, and Gregory XVI, although a good pope in many respects, he had some weaknesses, and he allowed the names of Galileo and Copernicus to be taken off the index of forbidden books. All right? Silently, without any explanation whatsoever, they were just taken off. All right? Now, come on, you know, we had 2 popes condemn this, send letters to all the papal nuncios and universities of Europe because it was so important. As a matter of fact, Urban VIII in 1632 had protracted discussions with the Duke of Tuscany, Cosimo Medici II, and told him what a terrible thing it was to have Galileo preaching the doctrine of heliocentrism, because it would ruin the church. Those were his words. It would ruin the church. And these letters went back and forth for over 6 months, where Urban VIII is trying to elicit the help of Cosimo Medici, the Duke of Tuscany, to help in this matter. But all the while, Cosimo was helping Galileo. Okay, as a matter of fact, when Galileo, this is where Galileo got in trouble, he published his book, okay, The Two World Systems, in 1632. And how did he get that accomplished if the church was really coming down hard on him? Well, he went to a cardinal in Florence named Riccardi, and Cosimo Medici was in on it, and they had a party, and they got him pretty blasted, if you know what I mean. And they asked him if he could have an imprimatur on his book, and he gave in. And they brought Caterina, the niece of Cosimo, to the party and, put her little wiles on the cardinal. And before you know it, this already weak man, who was now more weak than he was before, allowed this imprimatur to be issued for Galileo's book. So the Pope, Urban VIII, got wind of this a few months later and called Galileo down to Rome for a trial. Because he was told back in 1616 that not only should he not have written a book on heliocentrism, he shouldn't have even been talking about it, thinking about it, or doing anything about it. That's what he was told in 1616, okay, by Paul V. They let him go because although he was near heresy, they couldn't figure out whether he was really a heretic or not, because it's a matter of the will and the soul as well when you're a heretic. It's not just spouting a false doctrine, okay? So that ended up in 1633 with Galileo being titled vehemently suspect of heresy. Vehemently suspect of heresy. Just a hair's breadth from being a formal heretic. And that's how he got off the hook. Now, that was in 1633. This is how the church is dealing with science. What does the church do? The church does the same thing that it's been doing for 15 centuries before, which is what? It takes the Word of God, the Bible, at face value. Well, yeah, that's correct. When the church fathers came up against Matthew 26, verse 26, and Jesus says, "This is my body, take and eat," what do you do with that if you're a church father? Think about it. Is this man asking us to believe that his flesh is actually in that little host that looks like a wafer, tastes like bread, looks like bread, bakes like bread, dissolves like bread, and believe that his flesh is in that little host? Not only his flesh, but his soul, body, and spirit. Soul, spirit, and divinity. Okay? Well, that's a big jump. That's a big jump. Think about it. We as Catholics believe that. Now, that little host we receive on our tongue is God. Okay? I had a Protestant friend of mine tell me one time, he says, "You know what? If what you are saying is true, I would crawl on my belly up the aisle to receive it on my tongue." If I really believed that was God. So how did the fathers get to this point? Well, of course, they were led by the Holy Spirit, okay, who would lead them into all truth, to realize that though this looks like a piece of bread, and it tastes like a piece of bread, it isn't a piece of bread. And that took the church 1,200 years to come to that resolution. Because you might be tempted to say, well, maybe the bread and the body of Christ share the same space or something. Maybe that's what it is. And that's what the Lutherans came up with. But no, it's called transubstantiation, not consubstantiation. That means the bread's no longer there. It just looks like it's there. I can't explain it. But look at the dilemma that the fathers were in. we're going to bring this seemingly illogical doctrine to the world and tell them that this is the gospel and this little wafer was the guy who saved you from your sins and died on the cross? Yeah, no wonder St. Paul says that this message is foolishness to the world in 1 Corinthians chapter 1. Because it sure sounds like foolishness, but it's the truth. It's the God's honest truth. All right? But what we're after right now is the hermeneutic of the fathers. The hermeneutic, what's that? That's the interpretation they put on this passage, which was, no, it's not bread. It is the flesh of Jesus, and we consume it. Why? Because they took the word of God literally at face value. No ands, ifs, or buts. That's your church. That is your church. Okay? So what are you going to do when you come up with a passage in Psalm 93, verses 1 and 2, that says, the earth does not move? And in Joshua stops the sun and moon from moving so that he can have an extra day to defeat these 5 armies in front of him. What are you going to do with that passage? Well, don't you think it would be contradictory to say, well, we're going to interpret that metaphorically or figuratively, but this other passage in Matthew 26, verse 26, where it says, this is my body, well, we'll take that literally. Now, which is harder to believe? That Jesus has replaced the bread of a wafer, or that the earth doesn't move? Tell me. All right? So we're going to do a believability scale here. The earth motionless wins hands down. Okay? That's the kind of church we had. That's the Pope that we had in 1616 who said, Galileo, you're wrong. And why do we know you're wrong? Well, the Scripture says it over and over and over again, about a dozen times, in different ways. Okay? The fathers, and you grew up as a Catholic, you ought to know this, Galileo. What do we talk about with the fathers? We said when they're in consensus, and the Council of Trent had already occurred now, okay? And that was the council who told us that the consensus of fathers requires us to believe the doctrine that they're talking about. So you know that, Galileo. So let's go examine the fathers. And that's why I did a thorough study of the fathers in the books back there, if you want to pick them up. By the way, they're all free back there. Whatever book you want, you can have. Or if you want some for friends, relatives, whatever, you can take them, okay? Please, I want to get rid of them. I don't want to take them home. Okay, so Galileo knows this, that the fathers in consensus control what we believe. Now, of course, the magisterium has to confirm that, and that's why we have a 3-legged stool, basically. All right? But it worked. I mean, St. Robert Bellarmine said, the magisterium even approved the idea that the fathers in consensus on a particular doctrine, namely geocentrism, is our authority to decide the issue. Okay? So, here we have it. Here we have it. These are the same fathers that interpreted Matthew 26:26 as literally Jesus' physical body. You can talk about sacramental presence or whatever presence you want to talk about, but the fact is that Jesus lives there and lives in you when you take him. Okay? That's it. So, the church needs to restore its authority on science. Now, that may be hard, but the church has to know the science better than modern scientists. Unfortunately, we have another problem there, because a lot of these modern scientists are Catholic, or at least Catholic in name. And that's the problem with having a big church. You get a lot of nominal Catholics, you get a lot of sincere Catholics, well, not many sincere Catholics, you get some sincere Catholics, but you get a lot of nominal Catholics who grew up in a nominal home and had a nominal believing grandfather and grandmother and so on and so on. And they haven't really let that faith seep in deep and really believe in the Bible and what the church doctrine is and all that. So that's what we're up against too. All the students at Notre Dame, or Loyola in Chicago, 80% of those students there, they don't believe the Bible anymore. All right? And church doctrine, well, we can take that or leave that. All right? So that's what we're up against too. But, nevertheless, that's our job. That's what we're supposed to do. All right, so we do that. I just need to ask a question. What time do I stop?
You have till noon.
I have till noon. Okay. You want me to keep going?
Yes.
Okay. All right, so now science gives us data, okay? But there's something tricky about this whole thing, and that is, let's say I have an event that happened, and I wanted to figure out how that event happened. So let's say there's an explosion, and I want to figure out how that explosion occurred, okay? And let's say the sum I want to get to is the number 4, okay? The number 4, thank you. How many ways can I get to the number 4? 2 plus 2, 3 plus 1, log 3 of 16. There's a fancy one. Square root of 16. Okay? 1,000 minus 996. All gets to the number 4, right? So what am I trying to say? You can think of ways to get to the conclusion you want, but the addends that you use to get there may be totally false for the particular situation that you're looking at. Everybody understand what I'm saying? Okay? You can get to the same conclusion using a different route that looks plausible, and nobody could prove you wrong because we don't have enough knowledge or information to prove you wrong. All right? That's kind of life we have here. It's uncertain. That's what we lost when Adam and Eve decided to sin. Now we have to figure out which one of those pathways is correct. Now that's why I had put up the Earth going, or the sun going around the Earth. Okay? Because you know what? You can use the science and you can get to that position very easily. Very easily. Okay? And you can use the science to get to the reverse position very easily. What's the reverse position? When the Earth is going around the sun. Okay? So you have the same result, okay, but different ways to get there. Now, if you knew that that's a possibility, that you can use different addends to get to the same result, and you wanted to try to verify which one of those addends paths are correct, what would you do? Number one, you would go to authority, an authority higher than you. Okay? And in this case, we have the church. The church has been established by Jesus Christ. It declares dogma. We live by that, and the church has the keys of heaven to bind or loose. That's quite a bit of power. For the church to be able to excommunicate you and deny you heavenly glory, that's a lot of power. All right? So that's our first authority, and we go to them. What do we find? Well, we find that the fathers, as we said, believed in consensus geocentric doctrine and condemned heliocentric doctrine. Well, man, that's a head scratcher. How could that be if heliocentrism is the truth? You mean the Holy Spirit already misled the fathers of the church to believe a false doctrine? And why is that doctrine so important? Well, in Psalm 93, that I mentioned before, verses 1 and 2, it compares the motionlessness of the earth to the immutability of God. That's pretty heavy. God says he's immutable, And here's an example of it. The earth doesn't move. You see everything else moving in the sky, stars and planets and asteroids and meteors and everything, but there's only one object that doesn't move, and that's the earth, and that's an analogy to my immutability. So you know I will never change. Well, I can live with that. So that's why that doctrine is so important. God himself uses it as an analogy of who he is. Wow. So there's where you would go. You would go to the church that he established. And what does the church tell us? As the fathers are in consensus. And not only is that a consensus, there's no other doctrine that I can find in the Catholic Church, except for possibly baptismal regeneration, that has a total consensus of the fathers, without question, without doubt, as geocentrism. Well, that's an amazing thought, too. Every single father held the same belief. Now, baptismal regeneration comes a close second, if not tied. The Eucharist, not so. It has its problems. There is some patristic witness that equivocates on the Eucharist, and with good reason. It's kind of hard to understand, and we didn't resolve that problem until 1,200 years later. And even then, some people say we didn't resolve it, because, the accidens and substance formula of Aquinas, borrowed from Aristotle, that's a good mental image, but it may not be the best mental image, but that's all the church has, and the church approved it. So that's a hard one to understand. And there's other doctrines, but none of them come close to geocentrism. So if you want the authority, there it is. The Council of Trent told us, okay? And of course we have the Bible itself. It's the Word of God. It's inerrant. It's inspired. The only way that you cannot accept what it says about geocentrism is just to say that it's not inerrant. It is errant. And the Bible always errs when it talks about history or science. And that's exactly what our modern Catholic theologians today try to tell us. That at Vatican II, in Dei Verbum 11, when it said, for the sake of our salvation, God inspired the Bible, that means that only things that are talking about salvation are inspired by God in the Bible. So that means that everything else you read in the Bible, the history, the chronology, the mathematics, the geography, whatever it is, it could all be in error. That's what we're told today. That's what they teach in Catholic seminaries today. That's what they teach at Notre Dame and Loyola in Chicago, in Baltimore, and everywhere else. Okay? Unfortunately. But Scripture is our authority. It's never changed. It's always said the same. And the church told us early on that every word of it is inspired and inerrant in giving us propositional truth. Okay? So now where's the other area we go to? We go to science itself. Okay? Science itself. And in this realm, as I said, we need to know the science better than they do. And as I said to you, don't be scared about that. Don't be like, the Israelites were before Goliath. Because that's what it seems like when you first get into it. And I'm getting old. I need to raise up soldiers to continue this fight. Okay? And that means you need to go in there like Joseph did in Egypt, and you need to learn all the Egyptian ways, okay? Not for their benefit, but for yours, okay? So you have to learn the science, okay? And you can't think of this monster science, modern science, and I'm not ashamed to call it a monster because it is, and think of him as a 9-foot Goliath that is unbeatable, okay? You just get your little stones and you twirl them around, you knock them right in the forehead, and then you make everybody think about it, and sooner or later you may win that game. Okay, and God thinks long term. All right, and that's one problem I've had to deal with this. I've been at it for 15 years, but I think short term. I want the victory today, but it's probably not going to come in my day. It's just beginning. It's a pioneer work right now. And that's what we're stuck with. Okay, so if we're going to deal with science, let's go right to the root of the problem. You've all heard of this guy named Albert Einstein. Anybody ever heard of him before? A couple hands in the back, okay. All right. So I'm not going to be very kind to Dr. Einstein, okay? I'm going to tell you that right up front, because that's where the problem lies. Not only with evolution, but with cosmology in general, with paleontology, archaeology, you name it. It's all affected by Albert Einstein. If not directly, but indirectly, okay? And I personally don't think he had one good thing to say. That's how much I've delved into him. Now that may come as a shock to you, okay? But after I show you, and I may not be able to do it in this session, but we'll definitely do it in the next session, okay? He was the biggest enemy of the church has ever faced. And I do not say that lightly, all right? And it's interesting, you go and examine his life. His wife, Mileva, she became Catholic in 1905 with her family, with her children. And that's when he wrote his famous paper on the electrodynamics of moving bodies, okay? And to him, he basically said, yeah, no big deal. I'll move on. And eventually, her Catholicism caused a strain in their relationship, and he forthrightly divorced her, and he started to have a romance with his cousin, who was already married, Elsa Lowenthal, married to Max Lowenthal, already married, and eventually tore Elsa away from her husband, who was despondent over it, and married her in, 1919. And then he became infatuated with her daughter, Ilsa, who was then 19, and he was deciding in his memoirs whether he should have a relationship with Elsa or Ilsa. Okay? And that's just part of the story. But you should know who these people are. If we're going to fight the enemy, we need to know who the enemy are or is. And he has a sordid life that would make your hair stand on end, if I could give you some more details. But that's the world that we live in, okay? And some people think it's not fair to go into his moral life when we talk about his scientific life. Okay, I'll give you some credit there. All right? You make up your own decision, your own judgment on that. I think that the science is definitely affected by his moral life in one way or the other. And it is true with a lot of other scientists. I could go down a list for you and name not only their mortal sins, but their peccadillos also. Okay? You can't hide anything today with the internet. Everybody knows who everybody is. Okay? Unfortunately. Or fortunately. But Einstein, I'll start it for this 10 minutes and then we'll pick up later. There were experiments done in the 1800s by some very famous scientists that showed the Earth wasn't moving, was standing still in space. Okay? And this started way back in around 1818. There's a French scientist, his name is Dominique Arago. And if you go to the Eiffel Tower, I don't know if you've ever been to Paris or not, I just stopped over once and I made a beeline from the airport to the Eiffel Tower because I wanted somebody to take my picture in front of the Eiffel Tower. But if you look up at the Eiffel Tower, you see all the names of the famous French scientists that have existed in the last, say, 150 years or so. And Dominique Arago's name is up there. Okay, so he was a big deal. And he did experiments with starlight and telescopes, and I'm not going to go through all the details for you, but what he found was all this evidence points to the fact that the Earth isn't moving. Okay, and you can look up his stuff, it's in my book, Volume 1. Okay, all in great detail. I left no stone unturned when I did my investigations on all these scientists. Okay, so every detail is there. So there was a few other scientists who got wind of this, and they wanted to try to silence it. One of them was Augustin Fresnel, and his name is also up on the Eiffel Tower. Okay, Augustin Fresnel, very famous French scientist, dealt with light, and he tried to explain it away. Remember how I told you the different ways you can get to the number 4. Okay, 2 plus 2, 3 plus 1, log 3 is 16, square root of 6. Okay, well, that's what he tried to do. And he invented this formula called the Fresnel drag theory that said, well, the reason that Arago had his results was because since the Earth is moving, it was dragging the ether that was in his telescope so that he would see the starlight in a certain way, and that would make it look like the Earth wasn't moving. Basically is what happened. Okay? So you can see he's trying to get to this number 4, but he went around it another way. Okay? How do we explain this away is what he was really motivated by. Okay? And as I said at the beginning, that is the motivation of modern science today. They are motivated by one thing. Let's get God out of the picture and we'll explain everything naturally. Whether it works or not, we're going to do it. But we're the scientists, you see. We're in the white lab coats. We have the degrees. We have the sheepskins on the wall. We have prestige. We go on television. We write books. We appear in magazines. We're interviewed all over the world. So what do you think is going to happen to these measly little students here who are trying to get their degree in Notre Dame, and they're juniors, and they have tuition bills up, you know what, and their only concern is getting through college and getting a degree? Do you think they're going to disagree with me after they've already paid us $50,000? No. You might get a few, but they won't last long. Okay? So anyway, that's what they try to do, Fresnel. And there's a guy, Armand Fuseau, who tried to help defend Fresnel when Fresnel's theory started to fall apart a little bit. He came in to help him. He's another French scientist. Okay? Then England got into the picture in 1871. And there was this astronomer, Royal, very famous astronomer, George Bedell Airy, A-I-R-Y. And he did an experiment with light with 2 telescopes, and this is worth getting into a little bit. He had 2 telescopes sitting side by side with each other. One telescope he left filled with air, and the other telescope he filled with water. Okay? And the idea was that if light from the stars came into the telescope, either telescope, okay, the water telescope would slow down the light beam of the star so that it wouldn't be able to hit the eyepiece at the bottom of the telescope. It would hit the wall of the telescope, okay, because it goes too slow and the light comes in at an angle. So hit the telescope, and then it would go right through the telescope and hit the wall of the telescope instead of hitting the eyepiece down here. Everybody with me? Okay. The air telescope would take the light beam, it would go down, and because it's going faster now, because it's in air, not water, it would hit the eyepiece before it would hit the side wall of the telescope. Very ingenious experiment. Okay. And what do you think happened? There was no difference. So what does that tell you? Well, that tells you the Earth isn't moving. Plain and simple. Okay? As a matter of fact, that experiment was called Airy's failure. That's how it was written up in the newspapers. Airy's failure. Why did he fail? Well, because he failed to show that the Earth was moving. Okay? So there you had another experiment, 1871. Now things are getting real sophisticated now in modern science, real sophisticated, because they're making equipment. We have the Industrial Revolution going on, so they can make equipment now that is very precise. Okay? It's amazing that this experiment came along at that very time when man's intellect was matching the machinery he could build to test for it, which he did. So you can imagine the hullabaloo this caused in the modern world. All right? We knew since Copernicus, is what they always say. We knew since the time of Copernicus that the Earth was moving around the sun. And boy, could I tell you a story about Copernicus. Man, I wish I had an hour I could go and tell you about Copernicus. How deceptive that whole thing was. Okay? You know that old common thing you hear about Copernicus? Well, you know, Ptolemy's model had epicycles. He had to put all these epicycles. Anybody ever hear that into his model? Yeah. Okay, well, you know what? It turns out that Copernicus had more epicycles in his model than Ptolemy did in his. Very few people know that. And you won't know it unless you do the research on it. Okay? And that's because this model didn't work. It didn't work. Because those revolutions of the heavenly bodies are just too complicated to put into a simple formula. And we know that now, and we still don't know exactly how those bodies revolve around one another. There are still anomalies left over, believe me. Okay? But that's another subject. So they did this experiment, 1871. They found out again, after Arago did his 50 years earlier, that the Earth isn't moving in space. And when we come back from lunch, I will tell you the end of that story. Okay? Thank you. Let's have some prayer.
So here you see the geocentric model. The Earth is in the middle, the sun is going around, and it's carrying the planets with it. Okay, that was the model invented by Tycho Brahe around 1590 or so. And this was the model that all the Jesuits were flocking to after Galileo, because this model showed how it could work, at least geometrically. Okay? If you want to see how simple it is, watch this little trick. See, all we do is change the centers, and we start the whole thing all over again. See? So there's really no difference between the two models at all, geometrically speaking. Either model can work. And at that time, in the 1500s and 1600s, nobody really knew a lot about forces and gravity and things like that have to be taken into consideration. And so the side of the Catholic Church that was going to stay devoted to the fathers and the popes, this is what they used. Okay? Now, as a matter of fact, even when the issue of the forces and the gravity came into play in which model you would choose, there were such staunch defenders of the Catholics' decision to condemn Galileo that on the opening pages of Newton's Principia Mathematica, that was his famous book, 1687, that basically changed the whole world. And it talked about gravity and forces and things of that nature. Okay, this was a monumental book. Nobody had ever written anything like this before. Okay, it explained to us why an apple fell from a tree. And the old story about Newton sitting under his tree, apple tree, and the apple falls and hits him on the head and wakes him up. And he begins thinking about gravity. What made the apple fall from the tree? Why did it go down? Okay, that was our, you know how, and the guy who discovered buoyancy and density, what was his name? Bernoulli, I think. Bernoulli, I'm not sure. Anyway, he yelled, "Eureka!" when he was in the bathtub, naked in the bathtub, and he was playing with some soap or balls or something, and he finally had this insight into what caused, buoyancy and density and all that kind of stuff. And Prior to that, people just watched these things occur, but they didn't know how to explain them scientifically. What made something do something and not something else, okay? So that's why the scientific revolution was so big, because it finally gave us an insight into why things were happening instead of just happening, okay? So that was before what you're seeing on the screen here. Okay, so it's easy to adjust these things geometrically. The question is, can you make it work by dynamic forces? Okay, and by that we're talking about gravity, number one, and let's say centrifugal force. We've all felt that, right? When we're traveling down the road and you take a sharp corner, your whole body wants to go to the right side if you're turning left, because that's a centrifugal force. Centrifugal means away from the center, okay? And then you have this other force, inertial force, called Coriolis force. And a Coriolis force is what makes our hurricanes turn left or right, okay? They turn left in the northern hemisphere, and they turn right in the southern hemisphere. And then you have to be a powerful force in order to make those hurricanes turn one way or the other, okay? So that's another force we have to deal with. But at this time, when these models were made, they didn't know anything about forces and gravity, okay? At least not in the mathematical sense. When you can put ideas into a math equation, and that math equation represents the reality, okay, that says something, right? But, you know, as much as we praise Isaac Newton for discovering gravity, all he really did for us was tell us how fast it reacts. He didn't tell us how gravity works. He had no idea what makes an apple fall from the tree, okay? He didn't explain it. He says, I'm not here to explain that for you. All I can tell you is how fast it falls. And it will fall the same rate whether you drop it from 100 feet or 10 feet, or whether you drop a rock or a feather or whatever it is, it's all going to fall at the same rate. 32 feet per second is when it accelerates. And that's what we have, okay? And then he made another equation, very famous equation, called F equals ma, force equals mass times acceleration. Probably the most famous equation ever in the history of the world. Because with it, we can send up satellites, and we can determine how fast the Earth, sun rather, is going around the Earth, and you can tell how fast the planets are going around the sun. But even that equation isn't all it's cracked up to be, because that equation doesn't cover everything that's happening. And the fact is that when they send up those probes and satellites, they have to add in certain forces. One of them is that centrifugal force I was telling you about. The other is the Coriolis force, to make those probes react right. Okay, so as good as F equals ma is, it's not ubiquitous in the sense that it covers all the areas that we need to cover. In the history of this, there's also, now how do I get out of here, and then what do I do here? Someone help me. So I want to go to the menu where this stuff is. That's it. Yeah. All right. So let's look at one matter that has come up. So there's been somebody who wrote a book just recently. His name is Father Paul Robinson. And the book is titled The Realist Guide to Religion and Science. Yes, thank you. And he's from the SSPX, and he does a fantastic job on the philosophy, history of philosophy, and Aristotle and Aquinas and all that. But when it comes to cosmology, he went off the track. And he remains a diehard heliocentrist. And the only proof that he put in his book, this was written, published this year, and I've been in contact with him, so he knows who I am and I know who he is, and the war is just starting, and I'll let you know how it goes by this time next year. And well, the only proof that he used for his heliocentrism is this thing called stellar parallax. Anybody ever heard of that? Okay. Well, that's an old proof, or an old attempted proof of heliocentrism, but it's been discredited. It doesn't work. It doesn't prove heliocentrism at all. Okay? All it does is show us that same basic thing I was trying to tell you before, that in order to get to 4, you could add 2 plus 2, or you could add 3 plus 1. Okay? Both of them will get you 4, but the question is, $64,000 question is, which advents are correct? Okay? You have 3 apples, one pear, or do you have 2 apples and 2 pears to get to 4? And it makes all the difference in the world. Okay? So your result, in other words, the ends does not justify the means. You've heard that old saying, right? Okay, so let's look at parallax, for example. Now he's got so many. I mean, I designed all these, but we tweaked them as we went along, and I forget which one was the best one. I think, let's try this one. No, that's not the right one. Here. That might not be the best one either. Just give me a moment here. Okay, we'll start with this one. All right, so on the left-hand side, let me make that a little bigger for you. I just canceled it out. Okay. What was I on this one? It's HD. Okay. Is there a way to expand this without going through all this meticulous? All right. So on the left-hand side, the Earth is going around the sun, and you have 2 stars. Okay, one farther away from the Earth than the other. And if we analyze these 2 stars over a 180 day or so period, we see that as the Earth moves, the angle that we see both stars changes. That angle is called parallax. Okay? So this is how we look at it from Earth, from that black box up there. You see the nearer star is shifting back and forth against the farther star. All right? Everybody understand that? Any questions on that? All right, so what we do with the geocentric, since the universe is rotating around the Earth, and the sun actually is going a little slower, this is what's happening in the geocentric. The universe is rotating left to right. Of course, it's right to left for you, but anyway, I'm going to do it from my vantage point here. And the sun is going with it, but it's going a little slower every day, okay? And that's how we get our 365 days in a year. Because the sun goes 4 minutes slower than the universe does in the rotation, okay? And that makes the sun go through the zodiac, the 12 constellations of the zodiac. Okay, so as the sun is moving in this backwards motion, it's going to do it in 365 days, and it's carrying the whole universe with it. And we're going to see the exact same parallax angle as we did in the heliocentric version, if you compare the 2 black boxes up top. Okay? So it's easy to see here, that's all geometry. Okay? Anybody have a problem or a question about that at all? Okay, great. So, that's all I'm going to show you for now. Then I'll get to more later. I want to go back to my old friend Einstein. Okay, so there was another experiment done in, who remembers what the last experiment I told you about was? Anybody? Let's see if you're paying. Airy's failure, yeah. And remember, he had two telescopes, and he expected that the one that was filled with water would make the light go slower, and therefore would not hit the eyepiece of the telescope. And if that was the case, he thought it was going to hit the side of the telescope, and if that was the case, then the Earth was moving. If it hit the eyepiece of the telescope, the Earth wasn't moving. Okay? You can look that up on your own on the internet. Okay? Now, so that was 1871, and then there was another experiment done in 1881, 10 years later, by a man named Albert Michelson. He was a world-class physicist. In other words, he's very famous for his previous work, and it was funded it was actually recommended to do by James Clerk Maxwell, who was a prestigious physicist in the 1860s. And he gave us Maxwell's equations, which we still use today. And so there's some very famous men behind this experiment. It's done in 1881. And what they did was they set up this thing here called an interferometer. And basically, the light comes from a light source. There's a mirror after that the light splits. And one light beam goes one way, and the other light beam goes that way. And then they make this light beam go back and forth a few times, give it some distance. And then the question is, which light beam is going to beat the other back here at the microscope, up there at the center? Okay? So the theory was that if the Earth is moving, then the light beam that is discharged from this machine that goes in the direction of the supposed movement of the Earth around the sun, which is pretty fast in their framework, which is 19 miles per second, or 66,000 miles per hour. That's a pretty good clip. So if this light beam is going in that direction, and the speed of the Earth is going in the other direction, so let's say the speed of the Earth is going this way, and I shot the light beam that way, well, the space should impede that light beam to a certain extent. And you can actually calculate to what extent it would be impeded. Okay? And so they expected that the light beam that was shot with or against the Earth, didn't matter, would be affected, but the light beam that was shot this way, that didn't go with the Earth's path, okay, would not be affected. And they ran this through everybody, and everybody said, yeah, that's the way it should work. Okay? It's just like if you were a swimmer, you're in the water, and let's say the water is coming at you, and you're trying to swim against the water, like the salmon do every year, right? And they just inch up, because they can swim a little faster than the water is going down. Well, that's going to impede your speed, correct? The fish are not going to be going as fast in the water if it's going against them, okay? So everybody thought that since the Earth was moving, they should see this wide gap between when these two light beams would reach the microscope. Should be a wide gap there, obvious gap. All right? And what did they see? Anybody want to take a guess?
Well, that gap is supposed to be caused by the ether, right?
Well, let's just say the speed of the Earth against the ether. If you want to add the ether in there, let's do that. They all thought the ether was there, and they had evidence for it, and that was even in Maxwell's equations, as a matter of fact. The whole thing was based on ether presence. So that was the going science at that time. All right? And that'll become important later when we talk about Einstein. So for now, let's just say that the beam going against space or ether, whatever you want to call it, okay, due to the revolution of the Earth around the sun, is going to go slower. And there's going to be a wide gap between those two light beams coming back at that receiver. There should be, if the Earth is moving around the sun. So again, let me ask you, what did they see? Almost equal. Almost. And that will become important too. Okay, they saw about 1/10 of the speed that it should be. Okay? 1/10. So they have 1/10 of a positive result. All right? And that'll become important later. But let's say for practical purposes it was 0. And what does that tell us? If both those light beams came back at the same time at that receiver, what does that tell us?
The Earth is stationary.
The Earth ain't moving. That's what it tells us. Okay? The Earth ain't moving. Okay? Now, these are world-class physicists doing this now. So they were scratching their heads and figuring out what the heck is going on here. And so they decided to do it again. They did it 6 years later, in 1887. And they got Alexander Graham Bell, who was probably rich by this time, with the invention of the telephone, to fund the whole thing. They made the instrumentation much more precise. They put the whole table in a mercury bath, which costs a lot of money. They made sure that vibrations as close as 500 feet away would not be felt. So they put this whole thing in a basement because they figured there was some kind of external interference causing this weird result that the Earth wasn't moving. Okay? So they did the experiment in 1887, and by this time Albert Michelson took on a partner. His name is Edward Morley, another top-class physicist. They did the experiment again, and let me ask you, what do you think the result was? It was even worse this time than it was the previous time.
0.1%.
Yeah, just right around there. You know, so hey, if you're going to make more precise instrumentation and the Earth isn't moving, what do you expect? You're going to get a more precise result that the Earth isn't moving. Okay? That's just the way science works. So that's what we call the data. That's the data. And next comes the interpretation of the data. Okay? So, this was a real head scratcher for them. Because by all intents and purposes, that ether, that space should have impeded that light beam. I mean, because all of Maxwell's equations were based on that. And everything they know about science was based on that. They could explain electromagnetic activity, magnetic activity. They could explain pressure, and all kinds of things they could explain by that. But here it was. It defied everything they knew previously. And so another scientist came along about 5 years later. He was in contact with Albert Michelson. And in my book, I have the actual letters that they wrote back to each other, back and forth to each other, in their own handwriting. Okay, I had to go to a special museum and look at the microfiche and search for those, and I did. It took me weeks to find them, but I did. And so they're all in their photocopy for you in the book. And so Lorentz is writing to Michelson. He's writing to Oliver Lodge, which was another premier physicist who lived in England, and said, "What gives? Can you help me explain this experiment?" And nobody could do it. Nobody could do it. So Lorentz, forced to come up with an answer, Hendrik Lorentz, a Dutch physicist, very famous, knew Einstein and everybody else around that area. He came up with a theory, and he said, okay, the reason those light beams did not come back to the source at the same time is not because the Earth isn't moving, it's because the length of Michelson's apparatus shrunk during the experiment. Okay? If you believe that one, I got some land in Florida I'd love to sell you in the central part of it. Okay? So in other words, what he's saying is that the length of, let's say the red lines, the length of that red line was shortened because the whole experiment shortened at that point. And the yellow barriers were not affected. They didn't shorten. Okay? Does that sound cogent to you? Not really. So, because it's like, what would make it shorten? But that's the only answer that they could come up with. Okay? That space shortened somehow and made that light beam come back at the same time as the other light beam. Okay? When the logical interpretation of that data is that the Earth isn't moving because there's no pressure on the light beam. Okay? So you see how you can have two different pathways to the same solution? Okay? The solution is make sure those light beams coincide when they get back to the receiver. Someone could say, well, it's because the Earth doesn't move. The other guy says, no, that's because the whole interferometer was shortened. All right? And so that was the going. As a matter of fact, there was another physicist in Ireland. His name was Fitzgerald was his last name. John, I think, was his first name. And he said, you know, I've used your explanation for the Michelson-Morley experiment, that's what this was called, and they laugh at me over here in Ireland. And he goes, but now that you say it, I will laugh at them for saying that the instrument can't shrink. And so we had the beginnings of a theory that had absolutely no proof to it whatsoever, okay? Because nobody measured the distance between those two blocks in the red light zone there to determine that something shrank. This was all theoretical that we were talking about. This means that they said it has to be this way, that the instrument has to shrink in order for us to explain the result of it. Okay? Everybody with me? Okay. So this laid around for a while, and they were still wondering whether it was right or not. And then comes along this guy named Albert Einstein. And Albert Einstein knew about the Michelson-Morley experiment, although they try to hide that from us today. They try to make it sound like Einstein invented a special relativity theory because he was looking at Maxwell's equations from 1865, and that would give it a little bit more prestigious appeal, you see, because it would show that he wasn't trying to have another answer to why the Earth stood motionless in the center of the universe. Because if people caught on to the fact that he was inventing special relativity to deal with this issue of the Earth being motionless, well, that makes it a whole different ballgame, you see. But if you can make it look like he's dealing with Maxwell's equations, well, that's on the up and up, okay? But anyway, so as a matter of fact, in his first sentence of his famous 1905 paper, the electromagnetic dynamics of moving bodies, somebody in the last period thought I said human body. Must be my, I don't know. Anyway, in the very first sentence he says, since tests on the Earth's motion have been inconclusive, something to that effect, I am developing this theory of special relativity. So he comes and tells us, you know, why what the motivation is. Okay, because these experiments show that the Earth isn't moving, but we know it's moving. And how do we know it's moving? Because Copernicus told us. Okay? That's what they were all saying at that time. We've believed this for so long, and we can see the motions of the planets and the stars all coincide with this heliocentric view. Nobody ever proved it. They came up with proofs like I showed you before, like stellar parallax. And at that time, nobody knew that there was a reciprocal to stellar parallax on the geocentric side. So everybody just believed that we had the proof of heliocentrism based on stellar parallax. Okay? But there was no proof. But can you imagine a world that would be turned upside down as much as it would be if everyone found out that science had been wrong for the last 300 years and the Earth was really motionless in the center of the universe? What kind of world would we have? Have you ever think about that? Everything would be changed. Everything that we do. And we would be headed back to God and the Bible and the saints and the fathers. This whole world would be changed. Okay? I can't think of anything that would be more monumental than that. That the Bible was right when it said the earth doesn't move? Are you kidding? Wow. And the church was right for condemning Galileo? And led by the Holy Spirit who wasn't on vacation in 1616? Well, that's comforting to know. Can you think of anything else that's going to change the world besides that? I can't. So a lot was at stake. And at this time, the evolutionary theory had risen its ugly head, and it was a two-headed monster now, Copernicanism and Darwinism at the same time. So any scientist worth his salt, with pride and the fact that he has his sheepskin on the wall from a famous university, he's not going to get into this stuff. So we've got to find a solution to this experiment. After all, we're scientists. All right? Everybody see the dilemma here? The tension that's going on? Okay? So Einstein comes along, he writes his paper, and he says, yeah, I think that length contraction is a great idea. I think that's actually what happened. And he had no proof either. Wow, that's interesting. Science succumbs to a hypothesis that it can't prove to one of the most important experiments ever done in the history of mankind, whether the earth is moving or not. Can you think of a more profound question of whether the earth is moving or not? And so they're now going to depend on a hypothesis that they say must have happened? Not quite. So what dilemma did Einstein get into with this? Well, the dilemma was, if you say that the equipment shrank in order to produce the result, what does that mean? Well, it means you also must dilate the time. Okay? Think of it this way. Here's point A, and here's point B. Okay? So you have a block of wood going from point A to point B. So if that block, as it's moving, shortens in its length, how much time is it going to get to take? How much time is it going to take to get to point B? Well, it's going to take more because it's shortened. The tip of the block is now shortened. So to get to point B, you're going to have to dilate the time. You're going to have to increase the time that it travels to get to point B. Okay? That's a natural consequence of saying that the length contracted in this experiment. See, there are consequences to your answers. You may make up the length contraction, but you're going to have to pay for it with time dilation. Okay? So that means time is not absolute. Time is relative. Length is relative. And if you have this block of wood, and it's traveling to point B, okay, and it's shorter than it was before, what is the mass of that object going to be once it reaches point B? Anybody? It's going to be more. Because now it's smaller, you see. Its volume is smaller, so that means it's denser. So that means it has more mass per unit volume. So now you have mass increase. Okay? Now you have another problem. Mass increase. Now, in order to get there, in order to have all these ad hoc adjustments, length contraction, time dilation, mass increase, what else do you have to do? They weren't out of the woods yet. Say again?
Velocity has to slow down.
No, just the opposite. C, the velocity of light, has to be constant.
C is
Yeah, what did you mean then?
the velocity of the object.
Velocity of the object, okay.
You slow it down.
Well, it's, we're just taking an arbitrary velocity, doesn't matter what the velocity is, yeah. Okay, so c, that is the speed of light, has to be constant. In other words, this is what happened, folks. You had two choices after this experiment. Either light is constant or the earth is constant. And by constant, I mean it doesn't move. Okay? Those are your two choices. And what do you think Albert Einstein's going to choose? Okay, his wife became Catholic. He was an atheist, a practical atheist. He followed Spinoza, and we heard about Spinoza today and yesterday. Okay, that was his mentor. All right. He divorced his wife, married his cousin, and was infatuated with her daughter, and then divorced his second wife. Okay, and there's all kind of chicanery going on. And he had no love for Catholicism. He hated the Catholic Church. He hated Christianity. And I can prove it to you. It's in my book. You can go read about it. So what do you think he's going to choose? Is he going to rehabilitate the Catholic Church and say she was right in condemning Galileo?
No.
Not on his life. Okay? So you stick with this, what is now called a special theory of relativity. Okay, we want to apply a name to it, because that gets us out of the problem, even though it's a haunted house of mirrors. Okay, where everything is not what it appears to be. If length can contract and time increases and mass increases and the speed of light is constant, no matter what happens, then wow, we've just changed it. We've reinvented physics from the bottom up just to take care of this problem that the Earth isn't moving. Okay? That, ladies and gentlemen, is the legacy of Albert Einstein and special relativity. It was all invented to keep the Earth moving because the experiments showed it wasn't moving. Okay? I can go into a lot of detail for you, but that's the gist of it. Now, here was a problem. As we talked about, if you invent a solution that's not a real solution, you're going to have many problems. And here was another problem he had. This little world he created for himself where length contracted, light dilated, time dilated, mass increased, and light was constant speed, was only in an inertial frame of reference. Now, an inertial frame is defined as either being at rest or moving at the same speed. Okay? So, for example, if you're in an airplane and the airplane is moving 500 miles per hour, but it's uniform speed, constant speed. Okay? That would be an inertial frame. So if you throw a ball up in the plane, it would come right down to your hand. All right? A non-inertial frame is one in which that airplane is accelerating or decelerating. So if that plane is accelerating and you try to throw a ball up, well, that ball's going to be affected. It's not going to hit your hand on the way down. Okay? You can tell us when you drive a car or, you do anything, basically. You're going to be confronted with those forces. They're all around us. Okay? So here's the issue. If this was invented, this whole length contraction, time dilation, all this stuff, where's the inertial frame that you're talking about? Where in the universe is this inertial frame? There is none. Why? Because that universe is filled with gravity and inertial forces everywhere you go. So there is no inertial frame to test whether this is correct or not. So he's basically invented, by a thought experiment, what would get him out of this dilemma without any proof whatsoever. Okay, now some people might say, well, when they accelerate a proton in a cyclotron, it gains more mass. So that proves Einstein's theory. No, it doesn't. So this is another situation where you have 2 + 2 or 3 + 1 = 4. Okay? If that proton is moving really fast, it's moving fast through something, and it's picking up that something on the way to the other side of the cyclotron, and it's going to have more mass. Very simple explanation. Okay? Because space is not nothing. Space is a something. Whatever it is, it's a something. Okay? So it's picking it up. There's an easy explanation. But they can't explain length contraction or time dilation. Okay? That's their problem. They can only do it in an inertial frame, and there are no inertial frames. Because the universe is not an inertial frame. Okay? It's a non-inertial frame. And that makes all the difference in the world. So, what happened to little Einstein at this point in time? Well, everybody was cogitating on this special theory, and so was he, until they all found out that it didn't work the way they thought it should work. And so they had to invent another theory to cover over the mistakes of the first theory. And that was 10 years later in 1915. And that's called the general theory of relativity. Okay? Now, the general theory of relativity went in one right direction, and that is, it said, look, we got to deal with these non-inertial frames. Gravity and inertial forces. We have to deal with them. And guess what happened when he did that? When he incorporated gravity and inertial forces into his theory, his relativity theory, what he found was that you could put the Earth right smack in the center of the universe, motionless, and have the universe rotate around it on a daily basis. Surprise, surprise. Okay? When you deal with the real things that are out there, that's where it led back to. But his general relativity, now the key word there is relativity, allowed him also to say that you could have the reciprocal of that, which is an Earth rotating in a fixed universe. Okay? And he would work out the math where that would be possible too. Okay? So there you have it. The very theory that he invented in 1905, special relativity, to take the Earth out of the center, was now overturned in 1915 with his second theory, general relativity, that put the Earth back in the center. It was just a matter of which one you wanted to choose. Did you want to choose the biblical one, where the Earth is in the center and not moving, and have the universe rotate? Or do you want the one of modern science, where the Earth is rotating in a fixed universe? Which one do you want? Well, which one do you think they were going to choose? Okay? So then we had another experiment come along, and what do I have to watch till 2:30? 2:30, okay. Don't fall asleep on me now. Okay, everybody keep awake. Is it hot in here, or is it me? Is it hot? Huh? After lunch, maybe that's it. Okay. Anyway, hang on. I got some exclusive information for you. You can't get anywhere else. You're going to want to hear this, okay? All right. It is another experiment. The same guy, Albert Michelson, he did another experiment in 1925 with the same kind of fix-up here, okay? But this time, he was going to test for the rotation of the Earth, not its revolution around the sun, okay? Did the experiment, and Einstein knew about it, a lot of people knew about it, and what did they find? They found 98.7% of what they call sidereal rotation, okay? That means they almost got 100% of a rotation, 24-hour rotation, okay? Now that was a perplexing little piece of information. The first experiment we did in 1887 showed that the Earth was not going around the sun, it was motionless. The second experiment we tried with the rotation now shows us that the Earth is spinning around 24 hours. Now, how can that be? Okay, now, if you're a heliocentrist, this is not good news. You may think it's good news because, wow, we finally found, one of our components, that the Earth is going around 24 hours. No. It doesn't work that way. Because if you're a heliocentrist, you need both a 24-hour rotation of the Earth and you need an Earth that goes around the sun in 365 days. If you don't have both, you don't have a system. Why? Because we have to explain the seasons. See, the rotation of the Earth only explains the day-night rhythm. It doesn't explain the seasons. In a heliocentric view, the Earth is tilted 23.5 degrees on its axis and always points to the North Star, and that's how we get our seasons. But if the Earth isn't moving, you don't get any seasons, no matter how many times it spins around per day. Okay? So this only tightened the noose on them even further. Because what was the geocentric answer to that? Well, the geocentric says, hey, this is right up our alley. This is positive proof that geocentrism is correct. Because we don't need to have an Earth going around the sun, obviously. Okay? All we need is one motion. All we need is the universe going around the Earth in a 24-hour period. Actually, it's 23 hours, 56 minutes, and 4.1 seconds. Okay? That's all we need. And all we need is the sun to go up and down at a 47-degree angle in that circular motion of the universe, and voila, we have geocentrism. But you heliocentrists have a problem, because you need a revolution and a rotation, and you only have a rotation. At least if you look at the experimental evidence. Okay? So geocentrism, hands down, beats heliocentrism, because we can answer all the questions that come up. Okay? And we don't have to create fudge factors like time dilation and length contraction and all this stuff. Or dark matter, if you want to add that in there, or dark energy, or all that has to keep the universe expanding. Because we don't need an expanding universe. Okay? And what else did Einstein's general relativity tell us? Well, it said that if you have a rotating universe, you also have great centrifugal forces on the outer rim of that universe. You know, like if you're on a merry-go-round and you're out on the rim of the merry-go-round, what happens to you? You have a force that wants to pull you off, but if you go into the center of that merry-go-round, you hardly feel it, right? That's called centrifugal force. So if you go, and if the universe is rotating and you go on the outside rim of that, or near the outside rim of that universe, you're going to have tremendous centrifugal forces. And Einstein said, yes, that's correct. You will. And what's going to happen to the speed of light? Well, if you increase the centrifugal force, you increase the speed of light. So it's not constant. Because where centrifugal forces are, that's a non-inertial frame. And the speed of light is only constant in an inertial frame, not a non-inertial frame. Okay? So you can see how convoluted this whole thing is. All right? But in the scriptural, the ecclesiastical answer is very simple. The Earth isn't moving. It's not even rotating. It's not revolving. It's still. It's fixed. It's immobile. And so much so that God uses it, as I said, as an analogy for his own immutability. Because it can't move. All right? So, let's look at, I got 10 more minutes, or 6 more minutes, it looks like. So let's look at some other issues here. Did anybody drive here from wherever you are to get Conception? Okay. Did you use the GPS in your car? You did? Okay. Well, let me tell you something about that. Here's a real story for you. Global Positioning Satellite, that's what the GPS stands for, okay? Now there's like, 24 of them up there. They all send signals back and forth to each other, and they have a ground station that's involved, and that sends signals, blah, 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 okay? Now the GPS, and this is one of the reasons, or one of the top topics in our movie that we put out in 2014 called The Principle. In case you haven't seen it yet, you can order it from www.theprinciplemovie.com. Okay? And it was a theatrical released movie back in 2014. And one of the topics that it covered is the one I'm going to tell you about right now. along with some other ones that I don't have time to tell you, but wish I did, maybe next year. Anyway, the GPS is important because the GPS satellites, in order to communicate with each other, send signals back and forth. And those signals go with the speed of light, which is 186,000 miles per second. Okay? But they have a dilemma. Because if you have a satellite in the east communicating with a satellite, GPS satellite in the west, and this one in the east sends an electromagnetic wave to the one in the west, east to west, and then you compare that speed to the speed that the one in the west is going to send to the one in the east, they're not going to be the same. Okay? And they will differ by 30 nanoseconds, 50 nanoseconds. You know, nanoseconds are pretty small, but if Einstein's theory is correct, then there should be no difference. Okay? But there is a difference. And as a matter of fact, the reason we found out this is we contacted the guy who built the GPS. His name is Neil Ashby. He's in charge of it, at least at that time. And he even admits that there's a discrepancy between east and west flow and west to east flow. Okay? And you're going to see in a second why this supports geocentrism. And we contacted another individual, a physicist who works for Navcom Technologies in California, but he's retired as of last year. And he contracts with John Deere Tractor. And you know today how they have tractors in the fields that are unmanned and they're controlled by the GPS. Okay? So our friend, Ron Hatch, who works for Navcom, as I said, he had to go into the GPS computers because he had to program the tractors for John Deere into the GPS to make sure everything was only up and up. And if you don't do that, what happens? Well, your tractor goes into the ditch instead of plowing your field, okay? So you have to get this thing right. And so there's where Ron first noticed that, and by the way, Ron is not a geocentrist, okay? But we use this information. Remember I talked about using the data of science to prove our claims. We know the science better than they do, okay? So Ron told us he had to go in there and he had to put a correction into the GPS system. And that correction came from an experiment done in 1913 called the Sagnac experiment. And Sagnac found that the speed of light was not constant. Okay? Neil Ashby mentions the Sagnac correction. Ron Hatch mentions the Sagnac correction, all to do what? To compensate for the fact that east to west signals are faster than west to east signals in the GPS, which all contradicts special relativity. Okay? So what happens in society is, in the newspapers, is they pre-program the GPS computers with the Sagnac correction to make it look like everything is normal and the light speed never varies. And guess what? And this supports the special theory of relativity that says that light speed is always constant. You guys get that? Huh? You guys get that? Listen to that. What they're doing is they're fixing their problem. They're not telling you about it, and then they say, and to fix it, we have supports Einstein's relativity theory, so everybody can go on worshiping our Einstein, and we'll never get to the truth. And what is the truth? The truth is that the Earth isn't moving. That's the truth. That you can depend upon. That you can take to the bank, and we can prove that easily, scientifically. And I can give you reams. That's why those books are so big. Because I go into every experiment ever performed to show you they all have the same result. Okay? Every single one. I go through every wrinkle of the church's history about this issue so that we miss nothing. You have it all to show you from Scripture, from church authority, and from science that, yes, we've all been bamboozled. Okay? Now, I have a minute left, so anybody have a quick question? Yes, sir.
Just speak just a minute about pole shift. I believe, I agree with it. Let's say like other poles, And are there pole shifts? And is there any talk about poles or pole shifts if the Earth is central?
Sure you can. You have magnetic polar shifts in a lot of places. It could happen here. It hasn't, but it could happen here. But it has nothing to do with whether the Earth moves or not. Yes, sir. Back there. Checkered shirt. He doesn't know I'm calling him. Yeah, you had a question?
Yeah, it's gone now.
What's that? Oh, it's going. Okay. Anybody else quickly? Yes, sir.
Mine is an appreciation because this Galileo affair is one thing that mainly people opposed to the church teaching and the church's position in many respects.
Yes.
Use. I told Hugh one day that one of our lecturers would argue that, you see, if the church was wrong, since the church was wrong in the Galileo affair, that the sun, that the earth is actually static and the sun rotates around the earth, the church could still be wrong, and indeed is, in abortion and contraception, homosexuality, among other things. So little did I know, and actually totally did I know, I didn't know completely that Galileo was wrong. And had I known, of course, I would have left my lecturer dumbfounded.
Well, let me reinforce something from the early part of my lecture in the last session, which was we can't look at science as objective. There is an evil intent. Not all the time, but a lot of time. There's evil intent because they want to get to a certain conclusion, and they will get there come hell or high water. And they know you don't know about this stuff. Okay? So it's like anything else in life. Money, sex, it can be used for good or it can be used for bad. Okay? So let's not leave science out of those two categories. Okay? That's the main message I want to get across to you. Anybody else? You remember your question?
No, but I have a comment.
Okay.
I just remember my one day I accepted this whole immutability of the speed of light. Yeah, we hear that God is light. But I think what I'm just realizing, light is a created thing. But that whole idea of God is light and the speed of light is immutable kind of go together. Do you understand what I'm saying?
Yeah.
So that's why, for me, I was like, oh, that makes sense. The speed of light is constant. Well, God doesn't change.
Yeah,
No matter where you are,
you can build an analogy on that, yeah. I can see that.
But
Let me give you something else that's
how
very
my mind's
important.
ready to justify.
I know I'm going over this, won't take but a second. And they contradict themselves because in the Big Bang, it doesn't happen fast enough in order for them to form the galaxies and planets and all the other stuff that they want. So they have to supercharge it. Okay, but if they supercharge it, then they're going against the limited speed of light. Not only for light, but for gravity. Okay, so what they do is they ignore all that. They create this thing called inflation. That it inflated to 10 to the 35th power in 10 to the minus 35th seconds. That's because they needed it. Okay, they couldn't build their universe unless they had it, but it violated the special theory of relativity. Oh well. We'll just make it happen real fast so nobody notices, and that's exactly what they did. It's just like a magician. His hand is faster than your eye. Okay? Then, when they get to the part that the universe has to expand, and this happened, with Hubble, and I can tell you a whole story about Hubble, but and then in 1998 they saw these supernovas, supernova 1A, and they said, well, the universe is really expanding faster than we thought it was expanding, and it's accelerating. Okay? So first of all, they had to invent dark energy to keep it accelerating, and they've never seen that, okay? But they need it for their theory. And second of all, how fast is that expansion going? Well, it's going way past the speed of light, I can tell you that, and they admit it. So what do? They abandon the special theory of relativity and they go to the general theory, because the general theory said light is not constant, they can travel any speed. Okay? So we're talking about, what do they call it? Triple Monty or something? I mean, they're just bamboozling us with all kinds of stuff. And who's going to ask the questions? There may be somebody like me. Who's going to listen to me, though? And maybe you guys are. Okay? Maybe they'll listen to our movie a little bit, but who knows, man? They trounced that thing as fast as it came out. All right? So, I mean, there we are. Yes, sir?
I just got to clarify, that speed of light is for a vacuum, and light does change in different mediums. So it's different in water, different in air, different in glass.
Oh, sure, yeah.
Just to make that clear.
So when I say light is constant, I'm talking about a vacuum.
Yes.
I'm talking about an inertial vacuum. Okay? Yeah, try to find one of those in the universe.
Well, that's the assumption that the universe is in a vacuum for their theories.
Yeah, their theories, exactly. But the theory says, general relativity says that light can travel way beyond 186,000 miles a second. Okay? That's his theory. It's not mine. I'm just using his theory to show how jumbled up his whole view of the world is. Okay? And since there is no inertial frame in the universe that I know of, do you know any place that has no gravity and no inertial forces? I don't. So we're going to have to run by general relativity. If we do, then the speed of light cannot be constant, and neither can gravity. Okay? So there we have it. Yes, sir, in the back.
Can geometrically, for example, Neptune be the center of the universe with all the planets rotating around it, geometrically speaking? And same question for Alpha Centauri.
Sure. That's what general relativity tells us. Okay? So what they do admit by that is that it is possible to have Earth in that place. Okay? But I'm not arguing for Neptune because the Bible doesn't say Neptune is the center of the universe. Okay?
How about without relativity?
What's that?
How about without relativity?
I didn't quite hear that.
How about without relativity?
Without relativity what?
If relativity is wrong, based on the evidence we have, could it be shown or inferred that another planet would be center of the universe with universe rotating around?
Yeah, I just said so.
Okay.
Yeah, mathematically, geometrically, you can do that if you want. Proving it's another story altogether. Okay? Having the evidence that it's true is also another story altogether. Okay? So, yeah, but that's the dilemma of general relativity. It's like a maze. You never know where you're going. But I'm going to use his information that allows the Earth to be the center of the universe against him. Sorry. And I'm going to use it to show that light is not constant, and neither is the speed of gravity. Okay? I can do that because I'm a scientist. Yes, sir.
I don't disagree, but if the Earth isn't spinning, can you explain how the winds are generated without the Coriolis effect?
There is a Coriolis effect. As a matter of fact, we have the same Coriolis effect to move those hurricanes in different directions as the heliocentric version does.
So you're saying the Earth isn't orbiting, but it's still
No, it's fixed, doesn't rotate. The Coriolis force comes from the rotating universe. In physics, if you look at Newtonian physics, the angular momentum of a spherical body rotating will create centrifugal and Coriolis forces. And it will create it to such a scale that it will keep all the stars and the sun rotating around the central axis of the universe. Okay? Now there's an instance where Coriolis force and centrifugal force are used as real forces. In the Newtonian framework of just the sun and the earth, the inertial forces, the Coriolis and the centrifugal, are fictitious forces because they can't fit them into the equation. F equals ma. They have to do so by hand. And they have to do it by hand because they can't send up a satellite or a probe unless they add in those centrifugal and Coriolis forces. But their equation has no room for it. Okay, but in the geocentric frame, our equations do have room for the Coriolis force because it's twice the strength of the centrifugal force, and that means it's going to hold all those celestial bodies in a circular motion around the universe's central axis. It all works physically. Okay, we've all worked it out. As a matter of fact, you can go on Wikipedia Look up Coriolis force, and at the bottom it'll tell you that the Coriolis force is twice the force of the centrifugal, and it creates a centripetal force on all the bodies in the universe, which keeps them rotating around the center. I didn't say that, Wikipedia said it. Okay? So there's proof of geocentrism right there, but who can go in there and pull it out and interpret it correctly? All right? But it's in my book. You can see how I do it and how others have done it in the book. There's many more people than me, dozens prior to me, who have done the same thing. And they show how a geocentric system works. Okay, so all the dynamics are taken care of. You saw the geometry all taken care of. Yes, sir, in the back?
Okay. Just a quick question. So you mentioned inertial reference frames.
Yeah.
Can you explain how inertial reference frames work versus just a point in space versus an actual physical object, such as the Earth?
Not quite sure what your question is.
I guess my question would be, inertial reference frames, generally the definition, there's going to be no acceleration acting on that object.
The what? Stand up so I can hear you.
So the inertial reference frames, you're talking about no acceleration acting on the frame.
No acceleration to do it, no gravity.
I'm just trying to figure out how you're using an actual object as your inertial reference frame, such as the Earth, because you will have forces acting on that object.
But those forces are counterbalanced.
Okay.
That's how.
Okay.
Yeah.
That makes sense.
Okay. All right. Anybody else? All right. We're done. Thank you so much.